for a bit. I'm just here with Jason, hang out, we talk about stuff, and then I'll let you guys be, if you don't mind. That is, Jason invited me. I was like, all right,
You should just stay on the entire throughout.
all right, let's do
We're
it.
basically live now. What do we want to talk about?
Anything. I know I saw that you posted on Twitter. You talked about engineering, growing engineering teams.
Yeah.
I think this week I've been going to the rabbit hole.
I know I
saw that you posted on Twitter. You talked about engineering.
Mute the
growing
YouTube.
engineering teams. I am muting my YouTube.
This is amateur hour.
I know, right? So yeah, I've this week I've also been trying to think through how to write unit tests for machine learning code. I don't know if that's something that might be interesting for your audience. But yeah, we can talk about anything you want. I'll let you take the lead.
The audience doesn't matter. We're just chatting. I also feel like you would actually know more about like how to be testing these things because you are doing like these LLM systems in production.
Yeah, for sure. We can get into that. I think obviously it depends on what part of the stack you're testing, and I think, yeah, sure, you can. And I think the analogy of a unit test and like end-to-end tests like maps to like parts of the stack. So I don't think so. You totally throw out of the window. I can talk about a few things. So I saw a tweet recently about somebody referencing like unit tests for machine learning code, and so they reference like PyTorch's unit tests, and there's some examples to do that. There was some other open source like repos where they're testing machine learning code. So I think TLDR, you heavily test your data pipelines. I think that's the part of the stack where you have to be very careful about testing. It's dumb things like deduping, like making sure you don't have nans and things like that.
Oh right, yeah.
Yeah, dumb things like when you're even preparing like training data for code or something like that, you have to be careful about those kind of things a little bit. Modeling side, less testing, apart from just like you always want to use something which is already pre-built. Like you don't want to write hand roll your own training loop now with like so many other libraries out there. You can introduce so much error if you're trying to put your own training loop in, right? Versus using Accelerate or Composer or something like
shuffling data.
Yeah, so you're almost exactly. So you're almost leaning on somebody else's kind of well-tested like suite of like things to do, and then eval sets and obviously have like some Python basic PyTest unit tests that you're like loading data correctly and things like that. That's kind of what I have roughly as a map.
So maybe I can just dive a little bit deeper into that.
Yeah.
I'm specifically, so imagine I'm a developer building a new system or a new app that needs this bundle of weights. Now this bundle of weights is a black box. So you could imagine, many years ago, we would write logic in the form of if-else statements, etc., and we could test that logic. Now there's this bundle of weights that we want to. Now, how do we get this bundle of weights? We put in data, we put in desired behavior, and we get the logic in the model learned bundle of weights. So now, do we still need to test that bundle of weights beyond integration testing and evals? Can we shorten the feedback loop while testing the bundle of weights and the unit test? But the thing is, this bundle of weights is pretty heavy, right? Something that's usable is like 7 gigabytes of RAM. And then, okay, maybe that's not too heavy, but having to load it, download it, and then retest it. What's the right way to think about it? And sometimes the bundle of weights, it spits out something, right? But we might want to tweak that something. We might want to ensure that our token constraints are right. We might want to ensure that maybe it's a classifier. The classes, a neural network, the output is just dimensions. There's no specific classes. How do we get the probabilities? So things like that. So that's how I've been thinking a lot about like, do we mock the model? What cases are there where we cannot mock the model, where it's really important to actually test the model itself? And I've dug into, I think you mentioned Accelerate, right? Accelerate actually splits it up into slow tests and fast tests. And they actually have a mix of they actually don't mock the model. They actually take the model configuration and just test the model configuration itself with empty weights. And then there's also times whereby they actually download the entire model. So that's when it's slow tests. I guess that's a nightly build process, etc. So things like that, like how to organize this. And imagine you're doing this across dozens of projects in an org. So you want to kind of think about best practices that developer velocity, how to increase that, as well as, but yet deploying safely, things like that. I don't know if you have any points to add on those aspects, or maybe you just say, hey, just test on the model all the time. I think it's just the trade-off is worth it.
I do think like if you just say like, okay, let's just instantiate the model, don't download new weights, init everything, there is a set of tests that just says, okay, just like run
Yeah,
the random
yes.
number through it and make
Exactly.
sure that like the distributions are correct.
The variances and all
You
that.
know,
Right?
like yeah, exactly. Like should the variance like are the norms like infinity, in which case something is wrong, for multiple batch sizes, are we running into like weird errors where like the last
Exactly.
batch is not being
That's a
included in
common
data?
one actually. Yeah.
That kind of stuff. Honestly, most of what I would want to do in a production setting is just to do like smoke tests, right?
So that means you leave it until after the maybe pre-merge, you run the smoke test end to end.
Yeah, and I'm just looking at things like, okay, what are like, because I used to do a lot of like work with embeddings. It was just, what is the change in the embeddings of the old model versus the new model? Is that like normal? What are the norms of these vectors? Is that normal? Stuff like that actually ends up being really helpful because you get issues where like norms go to infinity and you launch production, all of a sudden like the recommendation score plummets or increases.
Yeah, totally.
I would agree. That's why the scope of how I'm thinking about it is very, very small. Unit tests that you can either run on your machine or on the developer machine. So I'm not, of course, we can do whatever we need in evals, integration tests, load testing, etc. I'm just really specifically thinking about what software engineers or anyone should write when they're trying to wrap their application around a model, either pre-trained, a model that you can host on your own machine or a model that you just call from API.
Yeah, one data point I can share a little bit is because you're exactly right. You want to test the application wrapping around the model. So for example, we deploy models on fleets of Kubernetes clusters, right? Each of them has a container, like the model is behind a container. We're actually like, we download the model, and part of the deployment process is actually like downloading the model and like running like a forward inference pass. So you run something like a simple for code models, you run a simple print hello world, and that should basically pass, right? Or like have some kind of
May I ask how long does this step that you say take?
Yeah, so we've actually optimized it a lot, and I haven't worked on it. My teammate worked on it. Bradley, he's like this goated engineer. He was like engineer number.
There's like a blog post about
Yeah. He's like an engineer. He was engineer number 7 at YouTube. This guy optimized the entire like build time, like from like pulling everything in, tokenizer model, etc., to actually pushing it out. It's like to less than 2 minutes. Obviously, it's a small model, and so
really fast.
There's a.
What was it previously? If you could share. Like, I just want to get a ballpark of, what happens when you do it poorly or when you do it averagely?
Yeah, so you went it down from like 20 minutes to less than 2 minutes. And there's a whole talk on that. And like this is a whole CI/CD process to do it, right? Part of it is running those tests like that. You're making sure everything works. Certainly on the application context, that's that. We can dive into like machine learning side bugs if you wanted. Like, you might have some ideas on like in testing inference. Like, how do you know, like, the OpenAI version of the model is behaving, that's painful. Or something like that. But yeah, I mean, that's just a data point I have from my work. Yeah.
Thank you. That's very valuable. So I think ideal at, Replit, best you can do is probably 2 minutes. Don't try to optimize beyond that. Yeah.
Yeah. I mean, this is mostly like a plug from Modal Labs. Modal Labs also has like done a lot of work on doing like very fast like weight loading across these like CDNs. So I think for them it's almost like 30, 50 seconds for some like smaller models, but at least in the embedding world. I don't know about like 20 gigabyte models, but things are still pretty fast. Like even with instructor, it's been like we have slow tests, we have fast tests, and then we have like extra slow tests.
Wow.
Right.
How do you split between them?
Yeah, so all the fast tests are basically we have like standard JSON that we've mocked up, and we're just verifying that like the JSON string parsing is done correctly, right? Or like the partials are done correctly. Or the fact that, the logic that are handling keyword arguments, like the configuration, right? It's like, if it is tool mode and you do this, make sure like JSON isn't a system message, stuff like that. Then we have the slow tests, which are the ones that run on merge that just test OpenAI, right?
I
and
see.
Then we have extra slow tests, which is in the slow tests, we just test one example, JSON is 20. In the extra slow tests, we will go to say, okay, let's parameterize it. For the name extraction, let's have 10 different examples. Let's also test across every single mode. So make sure that like MD JSON, JSON, tools, function calling all work. Then let's also test that against AnyScale, OpenAI, Mistral, Olama. I think my goal is to get to that point where not only are these tests for the instructor library, but also like evals so we can go back and say, hey, Together AI, you guys have regressed on JSON
Yeah.
sampling, right?
That's how I'm thinking about it. So as not to slow down my developers, I'm gonna split them into slow tests and standard tests.
Yeah.
Slow tests, basically you must run the full suite, be pre-commit and pre-merge. But for if you are just iterating small things, I don't want to slow people down with a very heavy unit test.
Yeah, we run a version of that, like it's synthetics, right? Actually in prod, so whatever models we are using, we actually have synthetics, like, running every X minutes or something like that, where we are checking, because OpenAI is notorious for, like, model performance drops. And like you obviously have a suite of evals running where we're actually, what Jason said, we're actually doing that. But you also have synthetics running otherwise, which are doing
Nice.
some kind of like fuzzy testing, basically. So combining a few
Yeah.
things,
Yeah.
My favorite thing is diverting like 0.5% of traffic into any new model and just waiting 5 minutes and like, great, nothing broke. Because it's like, yeah, there's smoke tests, and then there's also like shadow trafficking, which we used a ton at Stitch Fix, and that has saved like so much stuff. Like we basically have a staging model or like branches, and then 0.5% of traffic just goes into every branch. And so every time we do a deploy, we just have like, okay, like a new deploy happened. Here's the average similarity cosine.
Yeah, exactly. Yeah.
Here's the average like token length. Great, they look similar to before, or they're more or less based on what we expect. And then we can just like deploy. Again, not unit test, but
that sounds great. Yeah.
He's bang on right. Like we put monitors on like, deviation and like prompt to like response ratios. And like that's what it comes down to in production, right? Literally my service will be having monitors like prompt input length, prompt output length, ratios, latency, all that kind of stuff. Yeah. So that's how you productionize, right?
Datadog.
Yeah, basically Datadog. That's why they make so much money. But yeah.
Sweet. I think we've exhausted the heck out of this very tiny topic on unit testing. But yeah. Maybe Jason, you can share me some of your updated thinking on how you would level up SDs on generative AI. I have more thoughts on that. I've been thinking about that a lot.
I've gone the opposite end of just ends up just being Python skills. I think one of the things I talked about last week, I think one of the things I talked about last week was just like, like why take 30 minutes to talk about the results of an experiment if it only takes like an hour to set up and run? And what I'm really realizing is that like, okay, if maybe it takes me 30 minutes to set this up, but it actually takes someone else like 4 or 5 hours, right? So there's actually a lot to be gained in just having like better knife skills. There's like so much to be gained, right? Like, like when I set up a project where I know that I'm gonna make a lot of network requests that might fail, in the first iteration of that implementation, I add in retries using tenacity and I use disk cache. So I know that if I rerun my scripts, if there's an error that's unaccounted for, that like I won't have to start from scratch. But when I came back to this one engineer, I was like, hey, like how come like I mocked up this code, it took me 40 minutes. How come it took like a day for you? Like, oh well, I would run it and like I'd run into an error, and then I would have to like fix the code and rerun it. And I was like, well, this job takes 20 minutes, but if you failed 3 times, you've just spent the hour, right? So, okay, no wonder you have to spend more time to like predict the outcome, because these things are just higher cost. And so, like I don't run into like dependency issues, right? But if you try to run my code and all of a sudden you're facing like Pydantic V1 or V2, right? Just being told that like, hey, spin up a new virtual environment, run this code. If it works, let's then prioritize how to get this in production. I think a lot of it ends up being like this, well, in order for me to like fix this, I got to go get this tool. But if I got to get this tool, I got to fill up the gas. If I have to fill up the gas, I got to go find my credit card. And now you're like looking for your credit card to like replace a light bulb. I think a lot of that ends up just being like familiarity with your tools. Like I didn't expect that, honestly, but I found that to be actually quite true, right?
That's really cool, and it's completely opposite of how I've been thinking about, which is great. That's why we chat, right? Because we have different views, right? I think last week we chatted. I was sharing with you that hey, I think that for a regular engineer to be really good at building products on LLMs, they need an understanding of evals, which is how to measure and track they need understanding that these things are probabilistic, which is really just standard machine learning. And they also need to understand how to look at data, when to know when the data smells wrong.
Yeah.
But now it's far harder. It's now text, right? I realize now that all of this can probably, rightly or wrongly, be summarized into 2 words. And those 2 words are scientific method.
Yeah.
If you think about it, everything about what we spoke about is scientific method. How to measure, track, know when we are getting improvements, know when we're not getting improvements. Scientific method on the world is probabilistic, unlike code, which is deterministic, just like LLMs are probabilistic. And looking at a lot of data, how do we even understand the world except through data? That's the approach I'm thinking. I also think that, yes, having the right tools to help you understand this, maybe, I don't know, I'm just going to name some silly things like, hey, how can you use a pandas data frame to look at text better? How can you know what are the right tools? And by tools, I think, hey, if it's a classification task, what are classification metrics to think about it? If it's a summarization task, what are the right tools? What are the right metrics to think about it? I mean, someone who has never done this before will never know it's coherence, fluency, relevance, and faithfulness. So once you have those tools, you can start to think about it and decompose the problem and look at it with data. And that's how I'm thinking about it. I actually don't know if that's still the right track. That's going to be the shortest path towards upscaling and engineering all to use LLMs more effectively. But what do you think?
Yeah, I think it's like those are the skills you need to teach, like the L5, L6, like strong engineer. They just need to like be given a textbook.
I see. Yeah.
But I'm actually finding like a lot of the new grads, like there's like my sort of, I guess, like the lack of sympathy here was like, oh man, like how are you like planning so much? We could just like build the experiment, but just realizing, like maybe you want to build out some evals, right? And you want to do precision recall. So you write a for loop, right? And you write the for loop, and I write the asynchronous batched approach, right? With caching, right? My iteration cycle is so much faster because like every time I have one error, like it just goes down to like, again, 20 minutes versus like 2 hours. And like that actually determines whether or not you're willing to run the experiment, let alone knowing what to measure, because I can still tell you what to measure. But the code actually becomes a thing where like, if I'm not watching you write the code, I can't just like, hey, like you're running this for loop, but the GPT-4 call takes like 20 seconds, right? So
I guess the Jason,
just like 10 extra runtime.
Yeah, it's really a skill issue.
Yeah, so it's like small stuff like this, like we joked about like, oh man, like how come people need agent frameworks? It's just a for loop. It's like actually,
yep.
The fact that this is the issue, like, I think we have to be more sympathetic because we've been working with like the L5, L6 engineer most of the time, and so that is the thing they need to work on. They need to work on the scientific method.
Yes, that's the bias in my sample.
Yeah.
Can I just add an example of this? Like exactly what Jason's saying is this thing. How many junior engineers, when they're debugging Python code, I have to just show them import PDB set trace. That one line of code, like, just speeds up because they're trying to guess what's going on in the code. Nobody has set up debuggers and shit like that.
Like the model takes like a minute to load, so you run the code, you just watch it spin for a minute, and you get an error.
Yeah, but like just knowing your Python tooling like that, like just that one line, like, you just have such a fast, like, and I think it matters because you can hold some amount of information in your head. What Jason is saying, if you know your tools right, you're within a fixed context window, you're getting more signal out of it,
of
right?
Course.
And it's incredibly important. So I've done that. Like that one line is basically my way to summarize his point.
Yeah, and it's like knowing your tools doesn't make you 10% better. It really makes you like 5 times faster.
Exactly.
Right. Like
exactly. I agree. Yeah, because you iterate faster, fail faster, and therefore iterate to success faster.
Yeah. So it's like, it's an individual person. There's this like iterative loop of like how good are your tools. And then there's the larger loop of like how skickly can you get your metrics out to run those like scientific experiments.
This would be a fantastic debate at the AI Engineer World Fair. Ooh.
Which one? What's the like skill
like what do you think is key, right? There's tools and then there's methods.
I mean, in the long run, it's methods. Yeah, it's got to be your methods, right?
I don't know. I mean, that's what I'm thinking now, but I'm really playing devil's advocate to myself. I mean, like, so imagine, could a scientist just create the evals, and then the engineer just optimizes against the evals? Like,
I mean,
is that something that
works for a long time, right? Like, like this is why you kind of like allocate time and capital to like junior folks, because it's just like in a chemistry lab, like if your pipetting sucks, you have to like Like you have to like retitrate the same solution 3 times because you're like
Yep.
your hands are shaky, right? Like those are real issues.
It's the Google L3 version of converting everything to gRPC, right? Basically,
Uh.
you have boundaries set up, you have functionality set up. You're just like like doing some kind of like well-defined task with constraints, right? So
But I did kind of realize that like, man, like this really ends up like I'm actually running into the skill, like the coding issue more than the scientific method, because
So Jason, let me ask you this.
come in and fix the scientific method.
So let me ask you this. You are now a consultant company for petroleum. You're now a consultant for a petroleum company, and they want to use LLMs for whatever, chatbots,
Sure.
going through contracts, etc. So what will you do to level up these SDEs to make this organization ready to take advantage of this new technology now? Python skills is one.
Yeah.
What else?
I think a big one is just like
Not to put you on the spot here, but yeah.
I mean, right away, the thing I think about is, okay, like how much like red tape is there to like run experiments? Like, is it going to be like, do you need to wait like 2 weeks to get IT approval to get access to like a GPU for like 40 minutes? It's like what is the limiting factor? And a lot of it is like the bureaucracy first, right? The second thing is like, how easily can you access infrastructure, right? It's like, even at like a tech company, if I realize, oh, like I want to run an experiment that compares GCP to Azure, that's a month and a half gone.
Yep.
Right? It's like, let me go get right? So there's like small stuff like that just increases the cycle speed. That's like not even skills. Like
Okay, so let's imagine all of them have access to shared AWS accounts. Anyone can spin up whatever machine they need, set up the IAM roles they need. Everyone has admin.
Yeah.
Unsafe, but also extreme velocity. What next?
Then it's be like, okay, as a data scientist, I would say like, what is the number we want to move up? What are the ideas we have to move that number, right? If we don't have a number, like I can come in and help and say, okay, we're gonna make up a number. It's like, it's not gonna be something we set a goal against for a year, but it's gonna be something we set a goal for the next 6 weeks, right? 6 weeks, let's just do like recall really well. Here's the definition, let's get educated. These are the problems. Now let's go run like 3 experiments. So let's look at the zeros, right? And then it's like, can we develop the skill of like looking at the failure modes and understanding what exactly is going on?
How do you do that? How do you teach error analysis?
I think a lot of it is like,
other than letting those errors happen. I actually don't know. Maybe it's a case study, just going through a lot of case studies of how these errors happen, or maybe it's like the senior sees that the error has happened, but just let the error happen to give whoever is co-piloting the chance to learn to pick up the error. Like, how can we learn this beyond actually going through the painful and long feedback loop of actually making the errors ourselves?
I mean, I think about the apprenticeship model a lot, where like when an error happens, you just have to pair program this out, and maybe even like this is like my hypothesis, which is like how I learned pottery, which is like, the instructor sits beside me, she makes something, and I just try to make it, and it sucks, and like that's fine, and then like she's done, she's gone, and I'm still trying to like fix it, right? Like I think there's just like a big gap in like how people exchange knowledge, and some of it you can write down, but a lot of it could just be maybe a junior person jumps on this call, and I just start talking about my ideas, and I'm like fixing this error, and like they're asking questions, and I continue to fix this error, right? And be like, great, I'm gonna go merge this in, you try to reproduce this or something like that. These are all hypotheticals.
Yep.
But I do think we kind of lack this like mentorship, apprenticeship model of coding. People just like merge code in, right?
Yeah, and I'm actually even trying to think how we can go beyond the mentorship apprenticeship, because mentorship apprenticeship
went there.
I think we can be there. I think so. For example, in my experience, I've been able to work with a handful of SDs every quarter and try to get this done. But the thing is, how can we scale this? Is it a training course? Is it a short book, etc.? So that would be cool.
I want to just acknowledge a question that was asked a little bit earlier.
What was the library? PDB?
Yeah.
Incredible. You can, I think you can actually run PDB such that when there's an exception, you automatically jump.
Yeah, exactly. Jeremy Howard has that alias in the command thing. I can share some experience regarding like mentorship and just like pair programming,
yes.
like that from a more industry context. Like, so yeah, dude. Like, there's so many times where it's like, especially when you're talking across systems. So when you're working at a bigger company, you're not just like working in your service in isolation. Like, so much of it is like talking to like all the AI surfaces I work on. They're talking to other things. Like recently I was writing a gRPC client for something like that, and yeah, I think sometimes it's like, especially about an external system, the pair programming model is so useful, right? Because you just get in and you get this entire context available to you, like when you pair programming, right? So huge fan of that. I think a lot of it is you build like debugging skills. So I think one of the things implicitly I'm just noticing when what we're talking about is like learning how to debug classes of problems. So if your confusion matrix looks like a certain way, you do have some intuition of how to debug it, right? Versus if you have a pydantic model going wasted like somewhere, like it's erroring out, like it's there's flakiness somewhere, right, in testing, in the tests or something like that, then there's a different procedure to run, right? And I think there's almost this notion of building a corpus of procedures, and I think a lot of it I have learned by pair programming with people, like and a lot of it is just you learn by reading and actually just doing the thing, like the way you debug model training, like a 3 billion model training is very different from like the way you run like a small classifier, right? So
Yeah, I love the example you just mentioned, which is the confusion metrics, right? I think pair programming extends, pair learning actually extends beyond just programming. So recently I was just sitting down with an engineer, and then this engineer was doing something, but there was this very minor defect that was happening, which is that the process was not idempotent. And they just keep trying, and then it looks about right. But if you look at a lot of data, you start to realize, hey, wait a minute, this is actually not idempotent, it's not deterministic. For that code that was supposed to be deterministic. So you could actually point it out, hey, this doesn't seem to be deterministic. They may not have noticed it because they may not have the intuition and the training yet to look at rows of data to realize that it's not deterministic. And that's why I think not all software engineers have that training to look at data, to pay attention to those small details in data. And I think that's helpful as well. Like you mentioned the confusion matrix, right? Like which quadrant of the confusion matrix is more important? Depends a lot on your application. So I mean, helping them think about how they should focus on the confusion matrix is also a very helpful scale.
Yeah, it just comes down again to like not only thinking about metrics, but also sort of codifying and systematizing the way you reason about trade-offs.
Exactly.
Yes, I love that.
Like, because if you have like false positive, false negative, that decision matrix, there are 4 quadrants, and you could talk about, you could break it into 4 things, which is each quadrant, or you could say, well, like, for all 4 quadrants, choose 4, systemize each of those.
Yeah,
exactly. Right? It's like, it's not just recall precision or PRAUC or ROC. It's like the business clearly wants to reduce false positives, right? Then that's what you optimize for at the cost of the rest of the quadrants, because that's what your downstream customers will see, right? Yeah. So is that level of thinking that you don't really see in a textbook? It happens through I
mean, it does. It's just not in the right context. Like in my like looks good to me K blog post, it's just like, okay, like what is recall? Recall is saying everyone is sick and everyone has cancer, but like you can't afford to test everybody. Precision is saying that like, okay, the dude bleeding from his eyeballs, like that guy's clearly sick, but everyone else is not sick.
Yeah.
Right. Yeah. I think if you take it to these extremes, you can like do some form of education. But yeah, a lot of it again is just like maybe the right way of doing it is just like one, classify and segment all possible types of errors by some definition, and then for each one list out, like enumerate the metrics you care about, and then also explicitly enumerate the trade-off you need to make, right? Like I think you could do it. I think you basically build a flow chart.
Let me ask you this. Do you think it would be helpful so what I'm thinking of is trying to write a playbook. So you can imagine text from LLMs, there's very many different kinds of text. There's classification, there's summarization, there's translation, there's code generation. So for each of these kind of texts, what kind of metrics do you want to care about? Do you think that would be helpful, or too much of a crutch, or no point at all, because they will still have to customize the metrics to whatever they think about?
I think if you did that plus had trade-offs, and so if you had that included trade-offs, so like all the decision making must be made under constraints, right? It's like and like we should probably try to enumerate all the different constraints. Like, is it a latency, compute, like ease of maintenance, like deployment? Like those are all trade-offs. Let's go pick 2, right? Again, like there's probably a world where like if there are 6 metrics, there's like two choose 6 trade-offs. Can we enumerate all of them? Be a little bit like exhaustive, and just like add in some anecdotes.
So essentially, what you're saying is summarize all the all the key decisions and the hotly debated topics from the past couple of design docs and put it there so people can learn from the trade-offs that other people have made and how they decide on the metrics, how they decide.
And having anecdotes for each one, right? Like that's kind of like the particle physics approach of just like there's some symmetry we're going to generate.
Exactly.
Now there's like empty tables. Let's go fill in this one. Like, what is the latency to maintenance cost trade-off? Well, if you make code very optimized and very fast, it's very difficult for new engineers to come on and understand this like hyper-optimized code. Go on.
And that's actually a way for us to go beyond the mentorship, where they can learn from the decisions that people have made in the past, rightly or wrongly. But of course, they've put in a lot of thought with all the trade-offs and thinking. And they can go through those as case studies and maybe learn a little bit about the implicit heuristics that were taken to address this.
Yeah, and I think if you think about it, like systems design traditionally has been taught a lot like this. You know, you read a lot about how different case studies, how Lyft solved this one problem, how Stitch Fix solved that problem, whatever, right? You know, and then you build this like kind of like, you know, this fuzzy database of experience, and then you can like, you know, combine things. So in fact, experience is a lot about given the space of possibilities, which Jason's talking about. Experience is knowing how to combine them, which to focus on, how you can reduce this combinatorial space very, very quickly, right? That's what like it's like this implicit inductive bias which you have, right? I think that's what is experience, right? I think systems design basically works that way. If you read all these letters and so on, right? You know, Bytecode is pretty good, and it's a lot of the way you learn systems design is there's no formula, there's no algorithm, right? I mean, sure, there's a playbook kind of thing, but you learn by looking at all these systems. So maybe that's one way to do it. I don't know. You know,
I think that's one way to do it. So one thing I really love is there's this repository online called Applied ML.
Can I bring it to the stage?
Oh, it's not on stage. I'll bring on the stage.
Let me add this now. Cool.
So there's this repository online, which I call Applied ML. It really is all the technical blogs and technical papers from industry that's actually been applied. I mean, you read a lot about, let's just say, recommendation algorithms, right? But how many of them actually make an impact on the customer? So I really love reading all this kind of applied.
You should hear like this is not like synthesized, right? It's like you can learn to like I do a lot of like jiu-jitsu stuff right now. It's like you can learn by watching all the matches. Like a good coach has just said, like at any point there are 3 decisions to make. Here are the 3 decisions, right? Like build up this flow chart. I think just there's not enough senior machine learning folks who are incentivized to write about it, because the academics are very incentivized to write about the academic results. So there's always there's like books on model training, but like the principal engineer is like very little. Oftentimes,
what are you talking about? I just read this great post from someone like what looks good to me at K. I thought that was pretty good. Teaches you to think about how to all the implicit thinking about it.
Yeah, because my incentives are different, right? Like if I was like principal at FANG, I would not be going like we need to think about precision recall.
Why? Why not? I challenge that.
Rewards. Yeah. Even when I was doing machine learning at Stitch Fix, like when Wired came over, and I was like, I got work to do. I don't need your little like interview. Like I have something, like I have deadlines and shit. Like writing is really hard.
Tell me about it.
Do you want to recommend some books?
Sure, yeah. So there's a question about some books on the bookshelf. I mean, Jason and I are sitting in my office. We're just hanging out, talking about stuff. Yeah, I think there's quite a few. I think it's always worth it to read. One thing I'm reading these days, I was showing Jason this Elements of Computing Systems. So there's that famous course, NAND to Tetris. It's based on this book. So it's like you build a computer all the way up from a NAND gate. So if you really want to understand computers, I think that helps. Jason disagrees, but we can discuss this. There are quite a few things, I think.
I got one book I always recommend, which is Designing Data-Intensive Applications.
Oh yeah, that's right.
Yeah, I don't know if you have that book.
Oh, it's right there. Let me get it.
But,
I mean, we should
Warthol.
We should ingrain that thing. You know,
this is like the first book I read after I graduated college. Very, very good book. It kind of just basically teaches you how to like organize things, and that's almost like enough.
Yeah, it's so important. Yeah.
Eugene, do you want to recommend one?
I guess if I so maybe along the track of engineering books, I actually really like The Pragmatic Programmer. I don't know if anyone has heard about it, but if you just Google, it really teaches you about how to be more pragmatic in your code, how to iterate fast. It talks a lot about processes, how to help yourself iterate fast, and unit testing the right things, etc. So that has really guided a lot about how I write code. That said, how I write code is pretty bad. So I guess we have another question that could be a lot more interesting. What do you think, Jason? Let's put it up.
If you don't work at a company and are building AI yourself, what is the best way to get that exchange of knowledge? I mean, I think a lot of it to me is like Twitter, Discord.
Yes.
But like you also, it's like very difficult to get knowledge by accident, right? Like if you want to have that kind of knowledge, you should be trying to set goals, even if they're meaningless. Set like outcome or process-based goals, hit those roadblocks, and then really try to like take the time to understand what that looks like, right? It's like if you just build a summarization app, like you're never going to learn anything because you're not going to know what to evaluate. But if you build a summarization app and say, well, I want it to be better. Okay, what does better mean? There's like factuality and like conciseness. Well, if I think hard about the product, like if I pass in a 3-hour YouTube video and it says this video is a lecture, it's a summary, but it's not very good. How do I measure that? Now you start doing research and figuring like, okay, now you go, okay, well, you know, like if the summary is very long, it takes a long time to generate these things. And now I have a trade-off of like latency versus the summary quality versus the length of that summary. Right? Are there like different ways I could sort of think about building this product out? And as long as you like give yourself a prompt and some goals that you want to actually move towards, you're gonna constantly like run into these walls. And your job is to like overcome those barriers. Right? If you just want to build something, you're really never going to learn that much. If you set goals like with obstacles, it usually becomes a lot easier to learn about these things.
Yeah, completely agree with what Jason said. Building a prototype yourself, understanding what your goals are, making sure you're taking time to measure it. And then the last thing, of course, is write about it. I mean, you've done all the work, take some time to really reflect and write about it and just put it out put it online out there on Twitter. Twitter is a super bad, it's like a bad signal, right? You put stuff that you're interested on Twitter and people will just find you as a bad signal. So now the other way that I would recommend doing this is, and I think Jason hinted at this, is like as on Discord, right? So one of the, and I'm going to post this in the link in the YouTube here, is that you could actually find, I know of a Luma where they actually talk about AI in action. So if you think about it, like these are actually people who build stuff and just share stuff every week. And then so they build it, they share it, and then they get feedback, and other people just share. It's almost like a informal community demo that happens every week. So you could do that yourself. I mean, like beyond just writing and sharing on Twitter, you could actually just go there and speak at a meetup. I mean, now that in-person meetups are hot again, I mean, speak at a meetup is a great way to find other interested folks. So yeah, plus one of that.
And just to add to that, I feel like, you know, somebody said like, oh, I don't know that much. Like, am I in the right position to write? Or like, I don't know that much. Like, am I in the position to like present? Like one, even if you say the wrong thing, you're going to learn something. Then two, there's a very little chance that you are literally the worst person on the planet. Right? Like if you are a week ahead of any single person and they see your content, you've just helped them save a week. Right? Like you don't need to be like years ahead to help somebody. Right? And even the obvious stuff, again, you have to realize that like everything that you read had to be written by somebody. And there's a lot of things that have just not been written. Like, you know, I wrote a blog post on just like how to use async.io, and it has like 5,000 views. And I was like, oh, okay, well, like,
yes, yeah.
You know, it's like it's a simple thing, but there's no chance that like I'm the person who understands it the least, like out of everyone. Like, and even if that was the case, by the time you publish it and you wait like a week, there's probably like 1,000 more developers who don't understand what like async.io does, and if they like Google and they find your blog post, you've already like contributed to humanity. And so, you know, I think the barrier to entry should be very low for this kind of stuff.
Yeah, I would agree, and I want to emphasize this point that Jason made, which is that you're not the worst person in the room on that. And if you think about it, your knowledge, expertise is really a ladder. You're gonna be somewhere on the ladder, and there's definitely gonna be someone below you on that ladder. So think about them as your audience. You're writing for them. You're helping them. Now, granted, you don't think about Jason or Andre Kapati. Okay, you know what? They're not gonna read my stuff. It's okay, because you're gonna be helping someone else, and that's fine as long as you think about it in that mindset. That's great. And of course, you know who benefits the most from writing? Yourself. Writing is a single player game. It's helping you to clarify your thinking, consolidate your knowledge, and it's a bad signal. So just do the writing anyway, even if you don't feel like you're an expert. It'll help you become better at what you're writing about.
All
This
right.
was great. We've got quite a few folks listening. Thank you. Super grateful. 12 people. Oh yes, Hamel. Yay. I know. I see
my
Hamel.
God.
Oh my God!
Whoa! I did not know you were in the room. Should I invite you? Wait, you have to get like dinner or something, right?
No, it's fine. We can invite him. We can invite him.
Hamel, do you want to pop on? I haven't talked to you in a while.
I'm at a
Yeah.
match today. Recently.
I am gonna ping Hamel. Hamel, check your Twitter. The StreamYard.
Oh my God, this is hilarious. We have a guest.
I don't know if he's maybe driving or something. I have no idea. Not sure if he will be able to join, but we'll see.
Let's see. Where is this guy?
That is so funny.
All right, we're gonna have Hamel join. We're gonna talk to you about the new latest blog post.
That was spicy.
Just show me the prompt.
Oh no, it's a fuck you. Show me the prompt.
Show me the prompt. Yeah.
That's so funny.
Let me.
This
Yeah,
is so fun. It's like this is such a serendipitous thing that you have a YouTube, I don't know, just live stream it, and then friends just join, and then now we can chat. It's really exactly what I try to replicate. It's just like if you can imagine, it's just like the AI and engineer conference, and then we're just at a cocktail party, and Jason and I are talking, and then Hamel overhears us talking, and it's like, hey guys, and then Hamel just joins the conversation.
It's great because like
This is
10
magic.
people to me is a lot of people.
It is a lot of people.
All right, let's introduce Hamel. He is an educator on weights and biases, as we all.
And I think the thing about Hamel is that he's like a super operator, just like Jason. I mean, I don't want to list out his resume and everything, but Hamel's actually built this shit, so he knows what he's talking about.
Yeah, thank you. Fun to be here.
Oh my God. Okay. So the thing that we talked about earlier was just like, how do we help engineers be better at AI? Were you there for part of that? We kind of split it on two things.
No, I just joined.
Okay.
By the way, I have to leave at 2:30. Just.
Oh,
letting you
I mean,
know.
this is not real.
Yeah,
It's
Okay.
all
This
chill.
is not you. Okay.
Okay. So one thing I kind of realized was like, I think last week my big feeling was, like, why are you spending so much time like planning out these experiments? Just go run the experiment. And then someone talked to me, was like, like not everyone is as like literally as fast as you, right? Like you think it's like a for loop and it's going to take you 20 minutes to run and maybe it takes 30 minutes, but for someone else, like they might run into another Python issue, like a dependency issue, like they try like multi-processing and then tried to async, but they didn't know that like you need to do like async gather, and now like they test like 1,000 examples and they didn't cache it. Now they're like running these like 5-minute loop cycles, and all of a sudden it takes like a day to run something. So I kind of realized like, oh shoot, like a lot of it actually might just be like coding skill before like the metrics, evals, et cetera, et cetera. I'm curious what you've seen. Like how much of it is like coding skill and how much of it is extremely high level, like I look at data, I know what to change in the model, I'm reading like ROC curves, I'm like making trade-offs between like precision and recall.
Yeah, my answer is a little bit less interesting. I think a lot of people have their calendars filled with all kinds of meetings and stuff, and like getting pinged on Slack and all kinds of stuff. And then what ends up happening is like, it's like the simple thing just takes all day because like constantly just doing one thing. Yeah, so they're just being like saying no to everything, being like, fuck you, no meetings. Then, I think that, I don't know, because like with us, like we can do that, right? Because we can just be like, okay,
Have you seen my calendar, man?
We have a polite version of that called Deep Work Day at Replit. We don't say "fuck you, no meetings." We call it Deep Work Day at Replit. So it's basically like, oh, my calendar. I'll be like, yeah, don't disturb me. It's Deep Work Day. So you're so right. Like, how the hell would I train a model if I'm getting pinged every half an hour? It just doesn't work that way. It just doesn't work that way.
I mean, on Hamel's point, I guess one tip I do is I block my calendar from 8 to 12 every day. I actually label it as deep work. I mean, my manager and my skip, they know that actually, if you need an urgent meeting with Eugene, just block over it. But for most people, it's just blocked.
Yeah, I think that's like I feel like that's only really like the senior engineers issue.
Hamel, let me ask you this question. Let me ask you the question this way. You have just joined as a consultant or advisor or whatever, joining a company. Let's just say it's a construction company. They have a lot of text data and they want to try to use LLMs. What are the key things you feel that their rockstar software engineers need to learn? Imagine all their software engineers are rockstars, need to learn in order to use LLMs effectively.
I need to like
And this is
look
a
at
yeah.
I think you need to look at data. You need to look at lots of data, become like a data janitor.
Wait,
What
they-
do they need to see?
Yeah,
What do they need to see in that data? No, is it errors?
yeah.
Is it like patterns? I'm trying to distill this because that's literally
Yeah.
what I need to do.
Like first you need to just see what is happening. Just look at it. There's always something happening. There's always some shit happening in the data that's wrong. Maybe it's like an instinct now, so I don't know how to articulate it, but it's like you can kind of just like you start looking at data, you can start to smell things.
How do
Like,
you teach
really-
people
really-
to smell this? Or how do you teach people this instinct? I know I'm probing a little bit too deep, Hamel, but I'm really trying to distill.
No,
this.
it's not too deep. No, it's not deep at all. So it's like reading data really carefully, which is really interesting because like software engineers like are maybe used to reading error logs carefully if they're good. Jason's like, I don't know.
People don't read messages, man.
They just copy paste in the chat GPT. Yeah.
No, they just send me the entire error log, and it's just like, Jason, like instructor doesn't work. Can you tell why? And then the error is like expected integer got string.
I can't. Data path does not exist in pandas.csv or no IAM permissions.
I know. So goofy. Anyway,
Yeah. So it's hard. I don't know how to help people with like they're not reading. That's like really tough. But like
Do you think a mechanism could be like, I don't know, at stand up we do bug triage where we look at data, like we spend 5 minutes looking at data together, try to force people to get into the habit? Or is it like deliberately sending them error analysis?
I'm actually doing the stand-up thing.
I think that's a good
treat
idea.
our RAG application as like an N+ first employee. So like on stand-up, it's like, okay, like Tony, what went well yesterday? What are you doing today? And then at the end, like, great, let's go look at the model. Like here were like 5 randomly selected thumbs down ratings for question answering.
I think that's a great idea.
One of the queries was, what happened lately? How could we possibly answer that question?
Yeah, you need
Right.
time.
Okay, let's take another. Oh, like a bunch of questions are requiring way too much context. What could we do to fix that? Okay, well now we brainstorm. Maybe you watch me brainstorm and say, oh, you know what? Like, what if we included like past documents that they've retrieved in the context? Maybe there's some idea of lately. Okay, well, and then maybe let's go another way. How many questions actually are like have this issue? Should we just say that should we just build a prompt that says like this is too ambiguous? Right? What are some ways of like pushing that question away? What are some ways of like improving the response to that question? What are some ways of adding context to that? Now we have like levers, right? Okay, when do we say no to the question? When it's like less than 2% of all volume questions, right? How do we detect that? Okay, now I need you to go write this like async batch job that just classifies whether or not, like here are 10 examples of things that are too like generic. We'd run that. Oh shit, it's 30% of the data set is questions like this, right? Okay.
I think that's the data.
Product issue, like can we just like stop? Can we like make it in the README or like in a question mark modal? Now you start being able to like play a lot around this.
I think in some sense, what Jason is saying is you need to be able to like slice and dice your data according to a lot of ways. So you start with the top level thing. Like, so this is my kind of roughly this process, and let me know what you guys think. You guys have worked with data quite a bit. It's like, you want to like start at the top level, like, just df or describe it. Like, what are you even seeing? What are the lengths of these things, right? You want to get as many top level things you want. How many duplicates are there? How many nans are there? You do your df describe, and then you start, oh, how many of these things you got wrong? How many of negative feedback things you got on your chat application or RAG, or how many, like, whatever, right? And then you start building ways for yourself to like slice and dice the data. So for example, like I do a lot of LLM training. A lot of it is like actually running the tokenizer over the data and seeing, okay, what's the compression looking like? If you have poor compression, by definition, that's kind of out of your corpus, right? So you want to start high level. The moment you're trying to see something, you want to build different kind of like knives to slice the data, right? So he's talking about classifiers, for example, be it like a tokenizer, be it even something like, just like a gibberish to like measure how much like, random characters are there. And like, that's how you actually build intuition. I mean, I don't know of any shortcut on sexy way. It's like, because the magic is in each dimension of the data, which you're slicing in and figuring out what's going on, right? So start high. That's my process actually, and I think it's worked over time. And you start high level, and you just start like building different axes to slice the data. Is it code parsable? Does this course have a lot of minified characters? As you measure by alphanumeric things. How long is this code, right? Things like that. So that's how I do it. Start very high level statistics, and then you build ways to slice the data, and then you do what Hamil's saying, which is actually read the freaking thing. Right? You just gotta read the freaking thing after, right? So,
one thing I do a lot, which is really uncool, is I build my own data viewers.
Yeah.
Like just use like Gradio, or this doesn't matter. Like use something. No one wants to. I don't know why. No one wants to do that. They're like, oh, like that's so stupid. But like,
this is the thing where I realize now, like maybe it's just a skill issue, right? Because when I think like, well, I'm gonna go classify like 10,000 queries, it ends up being like an hour to run the classification, and then I just run like a priori or like topic modeling, which also takes like 30 minutes, and then it's like, great, this is my intuition. Whereas like that's like I've done this for I've done the classify group like average score plots like 1,000 times.
Exactly.
Right.
Yeah, and
that counts,
value
group by
count,
value counts, value have described, like
value
my
counts,
like
all
pandas like ag dictionary construction is like over here. But I just feel like, like people don't know Gradio. People are like struggling with like Streamlit half the time, and like they that doesn't take the hour, right? That takes them like the entire afternoon to figure out like, oh, the state management isn't like I was too ambitious with this.
Yeah.
Like, and you're like,
no,
oh,
you have to invest time for sure, and like pick some stupid framework and learn it.
Yeah, exactly.
I've shadowed how Hamel does his work of improving output. It was just amazing to me that everything is just data, and he has this instinct to just know where the error is, what in the prompt or what in the retrieve context is making it wrong. And I guess the question I have is, how can I distill just 10% of what Hamel is doing and teach that to everyone else? I actually don't know. Maybe it's just a matter of just really going through the steps and learning. But yeah, and I know Hamel has got to go soon. Anything else you think that is critical that you want to share?
No, I don't want to detract from the data thing.
No. Yeah, just look at data. I fully agree with that. And I would just add to that, just try to look at the data and also try to quantify the data. Like what, okay, maybe you're just trying to extract JSON, and then sometimes it's errors. What errors? It's like JSON passing errors, not having the right keys errors, not having the right schemas errors. So quantify it so you can actually look at it over time.
I'll be happy to come on one of these if y'all do it again, by the way.
Next week.
I think we're just trying to do
It's a
this.
deal.
Like,
Next week.
Okay.
Same time.
Like batch summarize these and like turn them into notes that are more relevant. It's really just for fun.
Yeah, no, it seems like it's fun for sure.
So how this happens is that Jason and I have periodic catch-ups, one-on-ones, and then we're like, hey, the things we talk about here, I feel like more people could benefit from this. Why don't we just live stream? And this is the first live stream, right? It's almost like office hours, and you can see people typing questions in the chat. So so we'd love to have you on the next one.
Okay, I'll block my calendar. Is it 2 p.m. Pacific time?
1:30 p.m. PST.
Okay.
Yeah, you can see we way exceeded it. But of course, if Hamel says he's here, we're gonna invite him.
Cool.
All right.
All right. Well, yeah. Thanks
Yeah,
for
man.
having me.
Have
All
a
right,
great
I'll see you
weekend.
next time.
Sure.
All right. See ya.
Yeah. We're almost an hour now. I might have to go soon as well. Should we
Yeah.
end it off there, and then maybe we'll get the AI
Next
to
week.
summarize this?
Yeah, let's do that.
And journey some notes. All right, dude.
All right. This was super fun. Way better, like ran way better than I expected, especially with extra guests. Thank you.
Yeah, no, this is actually okay. These are incredible. Yeah. All right.
All right.
Let's end the stream now.
Wow, Flo, nice to see you.
Oh, do you know Flo?
Yeah. He's a regular at the paper club that I work with him on.
Awesome.
Yeah. It's crazy.
All right. Yeah.
All right. Take care, guys.
Take care,
Nice
guys.
chatting.
Stream.